Kale presented some examples of decision support information and tools that DWR and in particular the Yuba-Feather Forecast Coordinated Operations Program has our program is used and developed over the last 15 years or so. And I'm gonna take that apart a little bit and go, like I mentioned earlier this morning, more into first principles and make sure that we really understand what some of the component pieces are, so as we begin to think about that. And so I think it's and this relates to the question that was posed in the chat initially. So Kale talked about DSTs and DSSs. I thought, well, maybe a decision support tool is something like a hammer, and a decision support system is something like a toolbox and then some hardware. And then, but at first I kind of like this analogy, and then I thought, well, it's actually missing something as well. And so I think that we often confuse tools with information, and information without context and presentation isn't really useful. And I think it's the tool then that provides that context and information. So for example, you could have a hydrology model, and it creates forecasts. And so you just have a pile of forecasts, but you don't necessarily, you need to be able to display them. And so you understand, what's the forecast stage in relation to flood stage, and what it currently is. And so it creates context for that, and context with respect to how much has it rained and how much is it gonna rain. And so those are the tools. So I suppose that it's a tool that the hydrology model is a tool that uses other information to generate that, but it's still, you need a tool to be able to display the information and to put it into a proper context so that you can understand it. And so maybe that's a tool, but you still need a toolbox, and you still need a system to understand how you can combine all of this information into a context where you can make a decision, because you're not going to make a decision based strictly on the hydrology forecast. It's how does the hydrology forecast connect with what's going on elsewhere in the watershed and the water management tools, and then your understanding of the forecast meteorology, and the fact that there's maybe a levee emergency downstream. There's a whole set of information and tools that need to be combined into a system so that the operator or the emergency services manager or whomever or the administrator can make a informed decision about what needs to be done next, when, eventually, and in the future. So really, I think we need to kind of disassemble our notions of what information is, what tools are, and what systems are, in order to focus our efforts associated with the Yuba-Feather FIRO program and our development of decision support, information tools, and systems. Okay, so let's think about who the decision makers are in a FIRO environment. It's easy for us just to kind of jump to, since we're talking about reservoir operations, the RO and FIRO, it's very easy to think about, maybe we should just be reservoir operations centric. But even that isn't focused just on one person. So within reservoir operations, there's, a flood risk manager who may be the responsible Corps of Engineers individual who's overseeing the the management of the flood pool. It could be the water supply manager for the specific project when the storage is within the conservation space, as we've seen with other projects. It could be a hydropower manager who's really looking to optimize or improve the ability of the project to generate the most revenue and associated with hydropower generation for that effort. And there are other aspects of reservoir operations as well, which may relate to maintenance, facilities maintenance, or other aspects. So reservoir operations isn't just about making flood releases. It's about managing all the dimensionality of a storage project. Then in addition to that, we have emergency services managers that are taking the existing information and the forecast information and making plans about levee monitoring or evacuations or moving resources or notifying people. And so they need information, they need tools, and they need systems to be able to do their jobs effectively. And we don't want to forget about them in this process, certainly as well. There are resource managers associated with fisheries and recreation and other ecological and societal benefit resources that are very much need to be in the loop and are need to be served by our decision systems as well. And oftentimes they have their own, but they need information and tools and systems to be able to do a good job of that. And we have forecasters that are generating our weather and water forecasts. And they need information and they need tools and they need systems to be able to do their job effectively. And they're getting information from reservoir operations so that they can make forecasts of downstream stages effectively and more accurately. We have folks that are managing our observing systems. So they're out planning and working to make sure that the data keep flowing and that we're making observations in the right places and they're available in real time. And then when they're broken, they get fixed and that they're being assessed and that information is flowing into the right places so that people can access it and understand what it means and what it doesn't mean, and to help provide context for that information as well in terms of quality control and expectations for accuracy and reliability and latency. So observing systems, Cale mentioned this, are a really important part of the process as well. Okay, so we just talked about the observing system managers and their need for both decision support tools and systems and their role in supporting those of others. We talked a little bit about researchers and the research and operations partnership. So we have, modelers and developers who, very much need to be a part of this environment to, understand how information is being used, what tools are needed, how they're being used so that they can contribute to development and improvements in that as well. So our research and operations partnership works best when it is a partnership And it's not a matter of just throwing new tools over the fence and hoping that they work well, or new information over the fence and hoping that it's understood, but that we, attempt to get into each other's environment and understand what's involved and what decisions are being made and how the information is being used and what tools are necessary. It's really a pretty effective and enlightening process. And it's rewarding for operations people, and it's equally rewarding for the researchers and development folks as well. And then finally, we have a group of administrators. Sometimes we don't like to talk about these people, but they're important because they make sure that we get the resources and that we need to get our job done. They need to be in the loop, and oftentimes administrators are making the most important key decisions associated with emergencies. So when if we think about the Oroville incident in 2017, the decisions that were being made about how to operate with a compromised spillway were being made at a pretty high level, and not the regular people who are making the day-to-day decisions. So those administrators need to be informed. They need the tools and the information and the systems support to be able to make those sorts of decisions and to decide, we need to double down on human resources. We need to double down on physical resources to be able to conduct a flood fight or, be more effective as a community associated with handling an extreme event or something similar. So we don't want to forget about our administrators and our decision-making process. They need to be often provided with information of a slightly different type. It may be, maybe higher level. They don't have time to, spend, all day coming up to speed on something, and they need distilled information that kind of gets quickly to the point and allows them to be effective in what they need to do. Okay, so we're going to double back to our key questions: who, what, when, how, and why. And in particular, I think it's important to think about what information is available. So we're gonna really kind of focus on that next. So Kale covered some of this, but I think it's important to look at this kind of as a whole body of information. So I'm not talking about tools at this point. I'm talking really more about information that could go into a decision support tool, which would contribute to a decision support system. So the first class of information that is relevant for FIRO is context. Okay, so context is really important for almost everything that we do. So if you get information without context, you don't really know what to do with it. The sorts of contexts that are important for forecast informed reservoir information are what is normal, and then what are the current conditions with respect to capacities. So that could be reservoir capacity, it could be channel capacity, it could be generation capacity, it could be diversion capacity, those sorts of things. What are the constraints? What are the normal constraints, and what are the current constraints? Maybe the rate of change constraint below the reservoir is normally of a certain cubic foot per second per hour, but currently those constraints have changed because of conditions have been temporarily altered. So we need to know what the normal constraints are. We need to know what the current constraints are, if there are any shifts in those. We need to understand what our objectives are. What are we trying to do? Are we trying to keep the combined flow below 300,000 cubic feet per second at the confluence of the Feather and the Yuba rivers? What other objectives? What those objectives are important to know and to have integrated into our decision support system. What are our available resources? What are we able to garner with respect to getting people out on the ground, being able to make changes? What do we normally have available? What do we currently have available? What's the infrastructure status? Are there compromised levees downstream? Is everything in good shape? Is one of the generation units out? We have a normal picture of our infrastructure. How is it different right now? What are the economics? I mean, a lot of these questions come down to, the priorities come down to economics. Can we afford to do this? Or is this something that we need to avoid doing, or are we encouraged to do that? Those may relate to water delivery. They may relate to hydropower generation or recreation or other things. And what are our vulnerabilities? We should know where we have weaknesses in the system, or that where there are fragilities, and we need to be able to take that into account. And then finally, what are our agreements and what are the regulations? So where and how stable are those, and how critical are those? So being able to make decisions in the context of what we've agreed to and what the regulations are and how flexible those might or might not be is important context information for our decision-making process. So we take a lot of these things for granted in context, and the people that have been working in this case in reservoir operations for a very long time, they kind of take these things for granted. But integrating that information into our systems and making it clear and available is, I think, a really important attribute of what we should be striving for. And it gives our new folks an opportunity to learn and come up to speed very quickly. And it also gives us a foundation for just about everybody else that's working in that environment. So context is really critical. Kale touched on observations. Obviously, those are foundational to our enterprise and to operating the reservoir system. So we have ground-based systems. We have remotely sensed information from satellites and airborne platforms, and we have a contingent of experimental observations as well that ties into our research endeavors. Whether it's new soil moisture observations or ground-based radars or AR recon, or there are a lot of experimental new observation platforms that are we're working to integrate into decision support tools and decision support systems, and so we need to be aware of those as well and consider those. And going along with our observations, we have observational performance. So, what are the error rates? What's the reliability? What's the latency associated with all the observational information that's coming in? So we need tools to be able to understand that. Should you trust this gauge? Should you trust this estimate of precipitation or temperature or soil moisture or snow water equivalent? And can I rely on that to show up every 15 minutes, or is it going to come in a day later? And associated with the observations are the quality control processes. So in many cases, we're looking at processed information as opposed to raw information. It's good to understand and separate those two things. For example, CDEC is essentially a raw data repository and exchange mechanism. So there's very little quality control processed information there. But in a decision support system, you need to understand and whether the data are quality controlled, how they're quality controlled, and whether you can trust them. And maybe one of the decision support tools is a quality control process that helps you understand and improve the utility of the information that's being collected through the observational process. So that's a dimension that I think we need to be thinking about as well. And then model output. We've talked about, Hale talked about hydrology models. There are also hydraulic models. We have weather models, numerical weather prediction models that we've all become pretty familiar with in terms of at least what the models are and how we get at the information. And we need to be couching that properly and making sure that information is making it into our decision support system environment, and we have the proper tools to be able to interpret it. And so that's just the output from the models. And the reservoir operations model are in the same, but we need to understand, we need to have those models, and we need to be able to present the information and understand the information from the reservoir operations models as well. And then we've got model output, but we need to be thinking about model performance as well. I know that one of the teams that is involved in the Yuba-Feather PVA process is the verification team, and we're really, I think for the first time with this project, making some great progress on defining what the forecast skill performance is associated with a variety of forecast elements. And so to go right along with the model output, we need to understand the model performance in terms of skill, reliability, and latency, right? So we need to be able to provide, if you will, context for how we interpret our weather, water, and reservoir operations model. And these are all classes of information that need to pour into this decision support system so that we can begin to make sense of it and make release and storage and preparedness decisions associated with forecast informed reservoir operations. So that's a lot of information that we need to be able to deal with, and there's probably some gaps in what I just covered, and so that's the other thing that we should be working through as a part of this symposium is what are the information gaps, and that's and we should be doing that as well. So the next thing we want to think about is how should the information be organized and processed. And so if you just have a giant pile of information, it can be overwhelming. It probably is overwhelming. I was a little overwhelmed looking at some of Cale's slides in the beginning because there's just there's a lot of data, but what we really need to achieve through a decision support system is understanding. And so that involves organization, processing, distillation, and that's it's a heavy lift, but it's really, really an important thing for us to be able to achieve associated with this project. So if we, and we're going to look a little bit in more detail on that in a moment, but if we look at some of the existing and traditional decision support tools, and we're going to hear about some of those later this morning, and that'll be really helpful. Most of the tools and systems have been developed kind of organically and kind of independently by the separate agencies that are responsible for, different aspects of water management within the Yuba-Feather system. So you'll see some of these listed here. This is not necessarily comprehensive. So Yuba Water, has operational tools, and those are internal. I don't think I've ever seen those, in action in real time. Maybe nobody beyond Yuba Water has. We're going to get a glimpse into that soon. DWR's State Water Project has operational tools that are internal. So they don't like, you can't get on the internet and look at the tools that Tracy is using to make decisions about releases. Those are internal to their operations. The Corps of Engineers has spreadsheet tools, and they have the Corps Water Management System, and those are internal to their decision process and operations as well. DWR's hydrology flood operations has their flood emergency response information exchange, I think. That's external. It used to be internal. I think it's external now. And then they have CDEC, which is external as well. The RFC has, AWIPS, Advanced Weather Information Processing System. That's internal. They have their CHIPS hydrologic prediction system. That's internal, and they have an external website. So, and then CW3E has, obviously lots of modeling capability and systems that are internal, but they have an external website that folks are using. So, we need to be looking at how we take components of these as part of a system that can be used across the watershed by the key decision makers that I identified earlier to make great decisions, well-informed, confident decisions using the information that we have and the tools to do that. So there's also multi-agency tools. These are what we're on the cusp of developing now through the FIRO project. An example of that is forecast coordinated operations. So that is access controlled. It's not available to the general public, but it is available by multiple agencies on a password basis, so they have a common operating picture of what's going on. And as Cale showed earlier, and we'll show again in more detail later this morning, systemization of many of the tools. And then we have CW3E and SOMA water support for the Lake Mendocino major deviation. And I think Chris will probably touch on this a little bit, but it leverages that FCO framework and with links to key information. So the idea that you could go to one place and see how the model is working, and also have links to other supplemental context and forecast information. So these multi-agency tools are, I think, what we're going to be angling towards. So
Rob, just a quick check-in. We have about 7 minutes left, and we already have a couple questions in the chat box.
Okay, all right. I thought we were gonna have too much time, and we didn't. So that's good. So just as a reminder, our success with FIRO hinges on three things. It's developing and demonstrating FIRO water control plans work. We're doing that through the viability assessments. Secondly, and what we're really talking about here, it's equipping our decision makers with the right information, tools, and systems. And then thirdly, creating a well-defined long-term pathway for our research and operations partnership, and as well as the FIRO 2.0 concept. So those are our really our metrics for how we're going to be successful. And then lastly, if we look at what we really need to be doing as a part of building these decision support tools, we need to look at systemization of a water control plan, right? And so if you look at the water control plan in the center of this diagram with the reservoir operators, regardless of what, whether it's flood control, water supply, hydropower, other, they're in the box with the water control plan, and they're served by information associated with and tools associated with system configuration, constraints, objectives, the status of the system, the body of weather and water observations, the body of weather and water forecasts. And then we have these other decision makers that are kind of surrounding and interacting with this system, which spans from administrators to the various resource managers to observing system managers, emergency services, the forecasters themselves, and the body of researchers. So this is kind of how I'm proposing that we begin to think about our systemization of the water control plan and the decision support system associated with that. So we do have challenges associated with developing our DSS, if you will, and we're going to run into these in pretty short order. And they're fundamentally will reside in, where does the system reside? Who's responsible for maintaining it? Can we do something that is, virtual and appears to be on everybody's system, but is actually, shared? And then who has access? And then what do we do if, in a lights out scenario associated with managing the reservoir, and how does that relate to the tools and the decision support system that we develop?